looks okay.
Okay, that's good.
Well, I would have to like balance that thing for it.
Okay, yeah.
Down that area.
Okay.
I think this one's up there.
Screen.
Take out the shield. Yes. Things like that.
It's ready.
What else would they not would have been?
Perfect.
Your air conditioner fan.
So let's start our first lecture. Okay, just like more like introduction, so definitions, and then talk about what we're going to learn. If we look at the title, actually we include two parts, right? So one is the analysis, one is called the reverse engineering. So it's one of them, the way we're going to do to learn. Okay, and just move on to the definition. So we know, like we maybe from the cybersecurity, we cover part of it, like we introduced. So mainly the malware, we call the malicious software. So those specific purpose, we want to steal some information, disrupt or damage a system mainly. So we always say those purpose or behind. So it's doing something sometimes illegal, most of them they're illegal. And those types, including the virus, worms, trojans, and some like ransomware. So they're pretty common and always like happen. So they are all the activities, and it's pretty common. And when we're using different type system, OS, and then we always common. Then we'll go little bit more slightly more details like definitions. So those all the any software, they are designed to cause harm to the computer system network, then we can define it like this. And then those purposes, as what we say, like mainly damage the system, we try to steal the information. Most common right now we are using to steal the information. We try to get different user information and then doing scam or cause some like disruption, maybe something like the DDoS. So they try to make the service down, then it costs like maybe like financially or try to lost the trust from the customer. So all this. And we talk about different types, including the virus. So virus, the definition is about the like self-replicating program. So they will spread everything. So once you download the application and you double click like to execute it, it depends on even though we say the self-replicating. So some of it like you have to download execute, right? But or sometimes like when you, so how can we define like what's the moment? Like based on your like understanding, like experience. So you say, am I really, let's say there's an email. So do you think that once I open the email, does it cause the problem, or like do we need to, sometimes they say we do attach a file. So in which state? How do you think? Okay, so let's say we have the virus, right? So pretty common if we receive an email. So maybe it's a scam and then it do have an attached file. So which state do you think like when you open the email, then do you think the virus start to replicate, or do you need to really download the attachment and download to your local computer, and then or do once you download it when you execute it? So do you think that which state will cause the self replicate?
I think as soon as you could view the
Mhm.
email, but as soon as you try to click on any of the URLs or any of the links, then it's gonna
Mhm.
try to then begin access to your computer and download in the background.
Mhm.
Regardless of whether or not you see a download.
It's still done. And
Have there been attacks before where people have made it, what's that, when you viewed the email?
mhm. Yeah.
Pretty sure.
Yeah, So what's the, then how can we tell like when, what's the moment? Yeah, because sometimes it did happen when you open email. Sometimes when you really need to like download a file and open.
Person.
It's a technique we're using, but we need to know how they're going to do it. Then we know, okay, then we'll know, okay, is it safe? Let's say when we receive a message. Okay, so we have a message. So can we click on this message? Can we read this message? So pretty common depends on, then we need to know maybe the application itself. So if you saying, if this is based on the attachment, okay, the program we attach, then we have to download it, and or like in the execution state. Because you know sometimes you didn't really download the file, but when you open it, so we save it temporarily, right? So it's still like executing, open the file. So it will start the process like self-replicating, duplicate, and then spreading to your host. Okay, but if the application itself being hacked or like the injection, that means, okay, let's say we have we use the mail application using, let's say using a cell phone. Okay, if your cell phone, the mail application being injected, that means when the moment you open it, then they will start to replicate. So really depends on. So this awareness, like you need to judge, okay, if the application itself being hacked, or like they do have a backdoor, once they send an email to you and then you click on it, they will automatically execute. And it's really hard to prevent because in any moment when you open it, it will start. Okay, but most the pretty common. So that's why you see the lots of updates, like security update and upgrades, it comes out. So people always recommend, why do we need to like doing updating? Here's the reason, because sometimes they will realize, okay, they maybe have some backdoor, maybe there's some bugs, allow the hacker to inject in several ways. Long time ago, when you learn SQL injection, so because they know when we add the instruction action in the SQL statement, then they're able to bear. So later they fix it. Okay. So here's the reason in behind. So we need to know why it works then. Then how about the worms? It caused about the network. So without like attached to itself to a life. That means that we are really hard to prevent those worms. Okay. Maybe to the network, or sometimes we say using the DDoS, then it's more difficult to prevent it. Okay. And then the Trojan, we know that one is that we trick the user to think they are Legion's being software. So they're thinking they pretend. Okay. So if you try to download something from the third-party website, I'm not so sure if you ever look at some website, they provide the download source. Sometimes they do attach because some software application, they will fade out from the official website, or it's really hard to download. Okay, so you are trying to looking for like other resources. Have you ever to download some firmware pretty outdated? No. Okay. Let's say long time ago, I always like, is my story. I always say we installed the Windows system, right? For the I think after Windows 10, they will start from Windows 10 and 11. They will automatically, once you connect to the internet, they will download the driver by itself. Okay, but for the outdated, if I say like Windows 7, you say like before that, once you reinstall the system, you need to download by itself, by yourself. Okay, so if you have even the GPU, okay, you know we have that on board, they will attach with the CPU. We call the North Bridge and South Bridge, right? So one's for ALU, one's for the graphic GPU. So those are maybe for the sound card, maybe for the network card. Okay, so if you attach something else, even for your laptop too, like no matter desktop, laptop, once you reinstall your system, you need to download the driver by yourself or some like updated firmware. Okay, but sometimes when they're really outdated, or you're no longer to find it on their official website, then you are looking for some online other third-party website provide those. Maybe something really nice, they just upload it to let the user, but you never know. Okay, so that means like sometimes you try to download some firmware or the driver from those website, then maybe they will do some like changes. So they maybe like insert certain functions. Then you never know. Okay. When do you know? You know there's some problem, and then it takes your CPU to 100% processing power. Then okay, something is doing it behind. Then you need to restore again. So that's what happened to me. Okay. So always learning from this. We say we have the ransomware. It's pretty common nowadays, and I share this one. So they will encrypt the files, and then demands the payment, like we are paying by the bitcoins. So you know, and what's the life cycle? Because I asked like when they go into take execution. So always we talk about we have the called the infection state, and then we have the execution, and then propagation, and then we have the payload. Okay. So start with infection. So we will say it's initiate the execution, what we really deliver to the system or our desktop PC. And then in the execution state, so we really will activate, then running it. And then in the propagation, always you see no matter it's the Trojan or like you see the worms or virus, we always need to spread to the system, to the device, and then maybe they will search or scan any like connected devices, and even they will try to scan the info your maybe some internet connected device. You know, we have some software, right? Some application help you to scan the IP address connected to your internet. The MN, so I think in cybersecurity, remember, I think I showed one of application MN. So they can do the same. So they can try to scan what are the devices connect to your internet. And then they will try to port or like actually do you know based on the MAC address. You know what's MAC address? Okay, so you know the MAC address, the first few digits is representing the brand. Okay, so for different brand manufacturer, they get their own MAC address. So that's why we can recognize it. Okay, the system, and then the remaining would be the device. And if we are teaching another was the iOS, the smart things. Okay, so if I can scan based on those MAC address what I receive, then okay, maybe that one's a camera. So if you watch the news, sometimes why people like, even though I don't know, of course, sometimes we do have a battle for the camera, but also it's like, let's say if your PC being hacked or infected, then they will try to scan all the connected devices and then looking for, okay, if I know this one, okay, it's from the maybe TP-Link or the Blink, and the one I put for the camera, they'll know, okay, or they know, okay, they do have a battle, then they can spread some other program, inject other program. So that's how we're doing. And then propagation to other systems and devices. So they're working like this. And then later will be the payload. We call payload, that means the damage or effect we've been caused. And we'll go more details. Maybe we call some example, let's say infection. When we introduce to the system, it can be through the live phishing email, when you download some vulnerability. Those vulnerability will be some, maybe the application, maybe program or source code. We do have some something we didn't prevent. If you remember the one we talked about, the XSS attack. So XSS attack is like, because the program itself, or we didn't doing the prevention. So most pretty common if we try to encapsulation, that means change those input to a plain text, then we can prevent it. Okay, so maybe sometimes that's why we have input for email and password, or how can we validate before we send it to the server. Okay. And then execution, that means goes to the system. I think it's pretty easy to understand. And propagate, they will duplicate itself and then modify. So mainly pretty common when you see the CPU, or like if you're using a desktop, when you hear the CPU, after you try to install certain program, and then you hear the CPU, why the sounds like film taking off, right? So you know, okay, so that means your CPU taking 100% of the processing power. Then you're feeling, why? Normally, if you try to install a program, but it won't take that much like processing power, then you will feel, okay, maybe something working behind, then you need to pay attention. to it. And sometimes, when it's just loading, installing. So actually they also doing propagation. That means they let the virus or like some worm to like duplicate by itself. So you're thinking, okay, I'm installing, I'm waiting. Actually, you are letting the process to compete, being infected. Okay, so all this like be careful. I think I share this one is about the Adobe. Because I restore my my MacBook. Okay, you're thinking one of they already stop it, but the Adobe they do have a risk like the Wonder Fresh. Do you know the Fresh? Fresh? Do you know about this one? Okay, it's fade out because before for the website we do use a lot of Fresh to some animation or some effect. So they're using effect. One thing is that they do have a backdoor. So actually people criticize a lot and lots of things happen. To me, okay, because I need to install it and because I just restore my Mac OS and I need to install the Adobe, okay, the system. And then when I open my browser and then pop out the notice like on the top like this, there's a small banner. Okay, you do have you need to update your Adobe. Okay, yes, I just installed it, so I need to update it. So I click on the link and it start the process. It looks really similar. Okay, the installation page, like the program. Okay, so, but it's getting weird because it's taking so long time. And then I'm feeling when it start to like, you see the progress bar, right, running, then I feel like, okay, it's something not as usual, normal, why this, okay, but I have no way to stop it, okay. So when you really resize it and compare, so it's like I almost I remember that time we took my processing power and try to install lots of things, like lots of things pops out, or when you start to open your Chrome or Safari, and then it will keep like pop out lots of things. Okay, so only one thing, I will install the OS again one more time. So you see, so they always like execute like execution and then the propagation working together. And even we call it a payload, that means like sometimes it may be just like file encryption for the ransomware, and then for the stealing sensitive data, or something we call the key lockering. So all these things is the life cycle. Then we move on. So we talk about our topic. So how we need to like analyze it. So one is called the threat like mitigation. So we need to understand the attacks and what's its impact. And more important, so prevention. So we always learning. It's really hard to avoid it, and we will spend like maybe 40%. Most of them I say like 40% to effort like to doing prevention, and then most of the time we're doing the instance response. Okay, and recovery process. Like let's say, do we have a backup, and then how can we most of the time in other courses we always mention backup. The reason a backup is important is like no matter how we prevent it, it always happens. Then do we have like recover soon? Like we talk about the recovery and then backup. Because like really happen, let's say if we are server being like DDoS, then do we have a second server can serve, or do we able to like recover from the latest one, and then we doing the recovery? Okay, and maybe if you are the online shop, you are maybe 1 million user. So if your server down for maybe 8 hours, office hour, maybe you lost maybe how much? 1 million, 10 million? You never know how much. Okay, if you are some maybe some trading is more serious. So they always the target. And one is the one of the courses we were taking, the forensics, and then we just like getting some evidence for the legal needs. Okay, we're looking for clues. Sometimes like where the source, who are attacking. Okay, so we need to know. And here's the little details. So when we doing like we try to analyze those malware, like we can help for the security team. So now understand how the attack happens and how to prevent. So sometimes we need to know why and how it being happened. Then for that's why we can move on the second stage. Okay, based on we studying it, and then we know where's the backdoor, where's the risk, what are the vulnerability. of it, so we can develop some tools or strategy to detect, to prevent the similar way, okay, for the attack, and then provide the response. So those are, we need to analyze it, how it works, and then knowing the behavior, we can help for the investigation. Okay, so mainly we can trace the attacker's action. Okay, so you see when we're learning this one's for the legal purpose. Mainly like in the company, we always like report to the police or something related department, but as a part of the course, that's why you need to learn. Okay, but it's a more step. And next part, we know, okay, doing analysis. Then what's the reverse? Because we mentioned about the reverse engineering. So this one is the process to analyze those software, and we need to understand the functionality. Okay, and try to like uncover those like hidden behavior, identifying those like vulnerabilities, develop some countermeasurements we can do. And we have two ways to do. One is static and dynamic. Then what's the details? So for the reverse engineering, so in the type of, so we try to deconstructing a program and then to analyze its design and those behavior and then those functionalities. So we will look at like each function one by one. Okay, so we need to know what it's doing, and then how can the people, or like, okay, maybe some like possible, okay, let's say maybe you do really good prevention. Okay, maybe you are backdoor either one of the function able to be changed, or like make it easy to understand. Maybe you will set as a beginner, okay, you will write the global and local variables, right? So when you're learning programming, you know local and global variable, right? Maybe you, when you learn Java, you know we have the public and private. Okay, so let's say like this. Then what's the differences between private and public variables? What's the differences between private and public variables?
Public variables can be accessed by things outside of the province,
Class.
and private things can't.
Okay. Then in really practical, that means if a private can, let's say I have a class called a dog. Okay, if I have a class animal and I create a dog, and then it do have a called the name. Okay, variable. If I say it's a private, that means I cannot access it by, let's say, dot name. Then I can change it, right? So it's a public. Okay, so I can directly access the variable. Even I'm not the member of it, I'm not inheritant, or I'm some another class, then I can try to call this or no, directly access to this variable, and then I can modify. But it's a private, then I need to prevent. So most of the time we will set two functions, right? One is set and one is get. Is the most name. So get is I will return this one. So have you ever? So here's the reason why we make it so redundant, or like have you? That's why you need to think why we need to create private, and then we need to create two functions. One is called set, one is called get, and then to get the return value and update. So here's the reason why we setting it this way. Why we just, if we are changing it, or when you're thinking, okay, it's my own program, this function using by myself, then why you don't let it access easily, right? Easy, just directly access. Why I need to like set it to private and then protect it? Somebody we call protect. Protect belongs to the class inheritance, right? So you know, then why we need to do this? Then we will investigate. Okay, it may be if you're working as a team, sometimes you're not implement by yourself. If we have a big application, and then we will split all those functions, so you will pick up your own function and working on it. Okay, maybe you are the team, then maybe in the beginning when you design this program, you say, okay, let's get it easier to access. Okay, then I'll just let you set to public. That is if we use that Java. And you never know, because once, let's say we have another program like we call the maybe some virus. So I able to access your program. Maybe we call the email. okay, email application, that maybe is possible. So when you say it's a public, that means I can change it. Maybe I can change your POP server, SMTP server. Then you always receive the maybe some ransomware email. Then that's why I'm asking, like in which stage. If you have if you expose like those functions or like maybe some really sensitive like let's say your SMTP location, okay, URL, then really then you know it. So that's why you need to change to public. So this is a process for the reverse engineering. We need to like looking into all the functions. So this one is they help us to understand how it works. So this is important comes out, and then where you come from and how can we stop it. Here's a process. And we talk about like two techniques using, one is the static and another one is the dynamic. So static mainly is we look at the code without running it. So we examine those disassemble codes and using the compilers. Really, we just like go through all the line by line, all the statements and see, okay, what's the possible? Let's say maybe there's a one member, just like, okay, we have to define it as a public, but didn't change it, just make it as a, you say in the beginning, we say we have to make it as a private variable, but it changed to a public. I still implement, maybe when you use it, yes, we do still have the maybe get function, set function, but itself is a public. It's still okay, right? Because maybe you have another developer need to use this function, it won't affect you. But when you really test it, look at it, okay, I can directly access it. Okay. Sometimes most of the developer, when we're working on it, we follow our documents. Okay. So when we're working, I will see this function is getting the current date. Okay. So I will save the date. And most of the people will say, okay, I have a function get current date, set current date like this. But you will barely see, okay, let me try to access directly. As a team, we trust each other, suppose like things working like this. But for attacker, we always looking for this, the risk. And then for the dynamic analysis, it's like we were running the mirror in a control environment. Let's say we in the sandboxing or debugging to observe its behavior. Then why we need to do dynamic analysis? If we sometimes doing like, of course, there's some reason, okay, we do, guess why we need to like, okay, how come, maybe it's enough to doing static, well, if I look at our source code and then looking for, then why do we need to do the dynamic? We need to think about, okay, when we execute a program, and then what's the behavior, what's the differences if we only look at the source code and then in the stage, like when the program application is executing.
The source code might go somewhere that we can't see. And get something from somewhere else and come back.
That means they have some communication with the other, maybe some server, okay, returning. That means like source code itself maybe is safe, but when we try to, let's say we try to connect certain API, maybe we try to download maybe some, import some third parties, maybe some JS file, let's say it's a website, I will import from other third party JS file, CSS file, then it's possible coming up. And then what else?
I mean, with dynamic analysis, you can use multiple debugging tools to then see exactly where in memory or what's being stored in memory, and so you're able to follow it more accurately than just saying with the static, it might jump from here to here to here to here. So you try to piece that together, but if you run it on a debugger and walk it step by step, then you can actually see what it's trying to do and where it's trying to store things in memory.
Yeah. Maybe sometime in certain stage, okay, let's say we calling we have program ABC, function ABCD, okay, 4 functions. Maybe in the execution stage, okay, maybe from function A, suppose B and then CD, then you will see it's so weird. Why it's like from A, B, and then it jumps to another one. You never see, okay. And then it go back to C. I think this one should be, is it from cybersecurity? I forgot. So you will see the flow, so it will jump back. Then if you don't look at your, maybe when you look at your source code, you think, okay, when I define all the functions, calling all the functions, it looks fine, right? But when in actual execution, they will just try to inject, or the memory. So they will change, okay, maybe from B, then they will inject with it. Okay, after B, they will go to another function. Okay, the attacker like import this function. So after it complete the execution, it will go back to C and then D. So you never realize it. Okay, because the program looks fine, it will complete the whole execution, but actually they will try to inject. So those like will be in dynamic. Also, sometimes they will modify based on let's say like the memory address, right? Sometimes they will rely on, okay, once you start to execute, they would detect we're looking for, okay, this program, they use this memory location, and then they will modify the memory content. Okay, they will access to it and then change it. So maybe when it's static, you never know. Okay, and really you need to wait until, or they're looking, okay, it's some there's a function, or it's sending maybe the login information. So they will modify the login, maybe account or password, maybe credit card information in only execution state. So you never know. So that's why we do have static and dynamic. Okay, and because we need to know how the system or the program works. Okay, so that's why we say we need to observe its behavior. Okay, and we have different type of tools. We try to in the class I'm trying to let you to try and to look at some. And pretty common, I think most of you heard any tooth. I think the Wireshark is more like for the analysis is this one. Sandbox we pretty used. Maybe others you maybe not yet see it, right? Have you ever used the Wireshark? Okay, okay. Which course?
Sort of, it was computer networks, wasn't it?
From the network. I think it's networking class. Okay, you will okay.
It's a little bit forward, just
Okay, okay, a little bit. Okay. And even you can look at even most there was more details. Even simple, sometimes I would look at I say Google inspect, and then you check the network, and then the package. And I have another one is using called the POPC, so all the sometimes you can even simulate and duplicate the package. For me, I'm testing. So maybe you try to download certain content or like get certain information. We want to validate, okay, is this content or this package is the one affect certain type of actions or like change the data, then you can do it in this way, using analysis. Sometimes that, okay, let me duplicate this setting. Let's say I want to sending $1 to the bank account, okay, or send to somebody. Okay, if you capture this process, suppose we already encrypt it. Okay, if you're able to see, okay, this package is transferring $1 to another bank account. Okay, so maybe this package, it contains maybe the amount. Maybe another package contains the destination. Let's say the target account you want to transfer. Okay, and some attacker will try to simulate or duplicate this package. Okay, let me say. Of course, in nowadays they will prevent this one, but sometimes with the middleware and then try to doing this. Okay, maybe gaming is less lower protection. Let's say for gaming. Okay, if you want to hit something, okay, so when you try to, you see this package saying, okay, the damage maybe is 10. Okay, then you try to send this package again. Okay, so we can try to do the analysis and then like checking, okay, if I duplicate this packet one more time, does it the HP minus 10 again? Yes, then I will try to change the number to 100. And then say, okay, it changed to the damage goes to 100. Then okay, this package. So once you know this package specific, then you can write a program and then only sending this package to the server. That's not how it works. That's how we can use that. How can we use that analyze tool, and then we know, okay, based on this package is doing, and then we can just keep sending using writing. You can use Python or other program language, Java, whatever. We can do it. Okay, and those static tools help us just to setting the code. Then we can identify those like structure, functions, and the strings. And then the one we see, the one called IDEPO. So they are using, maybe we have the assembler or the compiler. Okay, something for a certain stage. Sometimes we need to, because you know all the programming language we are using, we have the interpreter, we have the compiler, assembler. So all these, like, it would translate to the machine language, like lower level. So sometimes like we need to wait until for some lower level, then you will know. And then for the dynamic, those we usually monitor those activity. So it's more like real time checking those activity. So, but most likely we need to set up a safe environment, and then mainly we look at those like network traffics and maybe some real time file, and then the system change. Okay, in the execution state. And then the forensic tool, we try to estimate the memory dumps, some this image, and then logs to identify those signs of those like malware infection. That's how it looks like. And always we try to do like doing analysis, especially for this class. We will introduce one thing about the virtual machine. Okay, so we always try to create a really safe environment doing testing, because we don't want to affect your system, right? And maybe you're thinking, okay, maybe we do have some files, maybe some document or like download a file. We need to do the investigation, checking them. We can create a virtual environment and then install those analysis tools, and those can isolate from our internet and other system, so they won't affect our original one. And then we always try to do the regular snapshot. Okay, maybe after you build up the VM and then create an image, maybe you save the image, because you know, like, especially for doing the analysis, we believe like every time after you execute, then it will crash your system. Okay, maybe being infected. So after you finish the analysis, then you need to restore it or recover from those backup and do it one more time. Okay. This behavior is helping us to save the time. Okay, pretty common behavior. And as well, we say create a virtual machine. So just like they will, the error will cause the harm to our system. So really crucial to perform the analysis, and then try to create isolate the VM so they can spread to other systems, mainly because our local machine, and then snapshot. That means the image we're going to be restored, so it's a clean state. So for the investigation, and also in this course, because when we are learning, so we need to know what's the ethical responsibilities. So make sure they're safe and privacy of a user, and maybe sometimes when you touch for analysis, because some information may be sensitive user, so try not to expose, or like you see, maybe you know if they are the trading company, some stock company, maybe some accounting firm, then they will be more like, maybe those information include the if you know they sending some information or for testing, sometimes they will encrypt or try to remove certain user information, sensitive information. But if no way to avoid, then maybe you see. So that's why ethical and also some like legal impact. So recommend. So just ensuring the laws regarding the malware handling and those computer faults or abuse as. So we need to of course you need to know, but you don't have to memorize all these things. Okay, wait. And then consents. So we are working only with the malware samples. You are authorized to analyze. Okay, and we try to get it. And here's the details, but I'm not going to repeat it. Just like those illegal and unauthorized access, we need to pay attention. And then here's the things where we need to know for today. And so why is the mirror, what is that, and then why is so significant to the facts, and then we will use the reverse engineering. So we look at the functions, source code, and then we do have a static dynamic to look at it, and then try to set up the environments. Just to let you know, as a first lab, we moving on, but not today. We can use the VMware to set up the first one. You can try to set up, and as a next lab, just need to try to set up the virtual environment. And one the VMware is free. I did try it, so it's called VMware Fusion. Let me see. Okay, so you see the VM. What you need to just download it, install it. You don't have, yeah, I'm not yet signed in. So just need to install it and then create a window. And later I will try to give you the one. Try to using the Ubuntu. So both you can try to install both image and in the lab. But if you think, okay, I'm okay to do it, I can do it earlier, prepare earlier, then you don't have to really come to the lab in the next week. Okay. And just you can prepare for it. Okay. So I finished this part and just show you more like details. Last time I just like cover a little bit about the top of the VM. And we also talk about, okay, so I talk about the malware, so we need to understand those including. So I just go quickly. So we know always we have the data and the code, right? So data will be the other information. So we're adding on, and then the code tell us like how to take action. So when we doing analysis, we always look in these two parts. Okay, are we going to look into the code or the data? Okay, so for the static, we always look on the code, right? And then the data, sometimes most of the data will be changing dynamically. So sometimes if we using the dynamic tools to look at it, so we will see the change, how the data like being modified, and then we add it. Okay. And maybe some data and codes, they are like intermixed everywhere. So we know that like exe file, HTML, JS file, so anything. And nowadays you know that we have the documents, right? X. So I think I mentioned. So what's the X representing? DOCX. What's the X? Have you ever paid attention to your files when you create a document file? You can save a .doc or .docx, or like for the new version, it always save a .docx. So what's this X represent?
Newer version.
This is newer version, but not executable. It's something. There's sometimes like why we need to like pay attention, or like, okay, just only one letter, we add one more letter. Then what's the difference? Okay, let's say I have the let's say I have a Word file. Let me see. Okay. So when I try to save it, you will see the Word document XY. And also I can change it to .doc. Right here, DOC. And if I by default DOC X, you can see the year, 2024. Okay, older version. That means like Microsoft, they try to introduce the Office. So you see the Excel, PowerPoint, everything comes with X. Then what's this X representing? And it comes something new. That means that we have the probability. That means we have a risk, right? Always when you're adding something. You know, Microsoft, they purchase this Office from another company. Do you know that history? Okay, so there's a company like the mainly is Excel. So Microsoft look at, okay, this really powerful Excel, they want to purchase it, so they bought it. So they took it. And they say they're rumor, but I don't know. I didn't have a chance, like didn't never work in Microsoft before. Have a chance, but they say their rumor say the backbone. That means the core code they are using long time ago. Okay, so that's why they say okay, they need to provide the security upgrade, change it. Yeah. Why now? I'm not so sure. Even the XML version comes out. I will say it. So, okay. So the X is called XML. Do you know what's XML? Heard about it? No. Okay, so yeah. So when you open the XML file, then you have some like text and so many things, content. Okay. So they changed the file format to XML. So that X representing they with the extension XML, and then you can import something or convert the PowerPoint to XML or convert the XML to a PowerPoint. Okay, more flexible. That means once they support one more feature, that means we have one more chance as an attacker. Okay, that means I'm able to access it or change the original file to XML and then retrieve the data, or I can try to modify the XML file and then change it. Let's say if I have a PowerPoint PDF origin file. Okay, so if I change the XML, maybe I have a hyperlink right there, maybe for education purpose. Okay, I upload it to DTL and I'm able to change it. So I change the XML link. So every one of you, like everyone click on this link. Then something happened. Okay. Or maybe we have the HTML, pretty common. We for the web programming if learn and other functions. Pretty common for the Java JS. And the function, because we will save it locally. We have the cache, maybe the cookies, all this can be affected. So this we need to do. Okay, here are some examples you can see. So maybe they would know some like capabilities for adversaries. So something like this. And then maybe some like I shared earlier to Ukraine 2022. So they were hacked into the satellite company. So they will like 1 hour before the Ukraine invasion. So they will stop it. So all this is possible. And then maybe you will look at here more like the machine assembly language. Most of the time you see we try to when we written in we call the high level language. And when we say the compiler, assembler, those, then when we convert, then maybe sometimes they will change it. So really, when they writing a program convert to low level language, you never know. So maybe they will access to a system. Okay. So most of attacker, they are not working on the high level language, but they will try to maybe change the compiler. And then maybe they're working. So right here, they will sometimes say, okay, if I try to jump or then larger than this, and then go to a system. So they will go to a more like sensitive location. Okay. So then we can use it for the command injection. So it's right here. And then FBI paypan. So sometimes they're adding it and then they will say, okay, shellcode connect to this one over the HTTP and send the local PC hostname and MAC address. So all this will expose all the sensitive information. Okay. And then we have the shell shock. So right here we have the malware, so we can working differently. So when we connect to the remote host, then we try to bind the connection of the certain part. So we open it. So especially for attacker, you see, we will always based on really low level. Okay. Because low level is directly access to your memory address, maybe the storage. So we try to gain the really high privilege to your system. Okay. So okay, you see, and put there a lot, but we don't have to. So it's more like the introducing. So even you say the Amazon Echo, so they will adding it. So if you really look into the memories, all the memories, there will be the hex code digits, and then you can translate. So we can look at it. So maybe if the Amazon Echo you use it, and then we will change the hex. And then when you want to play something, maybe they will use, maybe I change the URL. Okay. maybe suppose you want to watch something, then I always redirect and then or fit in you something else. Okay. So put it a lot, and then we have different way to choose the pretty common. And what's like maybe with the traces, some backdoor swarms, botnet, ransom. Okay. But when we looking into it, then but later when we have some exercise lab, then we can pick up something to help you to become more familiar with it. And there are some like common firmware we can look at it. So maybe we have some like bodies of the knowledge. We need to know, okay, those like attacker. So we need to know, okay, what's the behavior, and then where should we going to attack? So those information. And we do a different type of like the firmware we can go through, and then checking those like from the application, and then check one by one, and the hierarchy. Okay. Of course, in this moment, just like introducing, so you see tactics. I'm pretty difficult with the similar to your cybersecurity, just like we kept from those knowledge, and then when you know lecture, we'll focus on more. And maybe we say the one including the TDP, we say right here. Then we have more like some like large size. You can see application layer protocol, and then we can go down to the data like this. Okay, getting more ideas, getting more deeper. Okay, and one more thing, because we talk about the compiler, right? Maybe assembler. So those like the compilabilities, the object, machine code, and then from the programs. So we will link those the machine code, those like the object codes together, maybe with the static libraries. So we'll use it to form the library on the disk. So upon those like execution, so we know the load those code to the binary and then into a memory, and then also maybe some dynamic library. Okay, so this one is like more actual the programs, if you know. So you need to recall. Okay, if you based on the language you learn, no matter which type of language. So because like all this will go through the maybe we have called the interpreter or maybe the compiler to translate. So low level machine language. And then during the execution, so maybe those processes may still loading additional dynamic library. Okay. Then because we need to know is like when we're loading some dynamic library, that's why I say, okay, then we can try to inject. So those like steps. Okay. This like a key concept, because for the doing analysis, we need to know like in which state we have higher, like thinking from the attacker's perspective, we need to know what's the best timing or like for program execution. Okay, when can we attack it? And then for analysis, then we need to know, okay, then we need to focus on this process. That means like for dynamic, that's why we say, okay, we need to do dynamic using, yeah. And here's an example, we talk about two graphs, right? We have the compiler and compile change to, and then we have object file, library file, and then we have the static linker. Sometimes we including the dynamic linker. So we come say other libraries. So this one cool. And here's in the stage. So it's called executables. So those different various the binary executable files. So with different type format. And then we have you see some terms we call the ELF or like the P protocol executable. So all this will be maybe possible, affecting maybe confusing, but just have an idea. And then later when we have a chance to look into deeper, so maybe we maybe they will change the header. Maybe there's some like text section. Maybe they do have a data section. This how we access it. Maybe to the certain memory location that we can modify. For the linker, maybe we'll go to the header. Okay, the header, because sometimes we can know, okay, where's the virtual memory address. If you learn the OS, then you still remember we have the paging. Yeah, paging. Okay, so memory. So you know, refer to what you learned before. Okay, so if you remember, okay, if not, I'm not sure how many. Okay, so for the OS, okay, so let's say for the OS, if I need to work on this, let's say I want to link from the other files or like library dynamic, then I will work on the header file, the looking for the header. Okay, that means I know, okay, maybe it's from A, B, and then I say I want to jump to somewhere else and come back to C. Okay, pretend it. That's how it works. Okay. And maybe if I need to work on the data part, really change the content. Okay. Maybe that package or the memory location, I'm going to forward to other location. Yeah, maybe change the content. Then that's how it works. Maybe because the content, it doesn't mean really actual value of it. Sometimes content, including the data, maybe is the address of another memory location or other address too. Right? So still possible. So all these, just have a like rough idea, need to know, okay, maybe in the system, sometimes we have the tables and we have different session to save it. And we talk about for the PE, portable executable, that's for Windows. So the window format, so we also have the coffee format, so include those number headers. Just need to know for different system. Let's say we have Linux, we have the Windows, and that's why, okay, those virus, maybe when we writing a Trojan, really depends on the system. Okay, so you know, in different system, you see also depends on the user. Maybe the Windows is more popular, then you can write something focused on the window. Okay, and they cannot like cross like working. So if I'm writing a virus, like try to spread for the Windows, it only work for Windows. The reason why, because the format, just need to know the file format, how to, is different. So that's why the action is different. So you need to like writing a specific virus based on the OS or the system or device you want to hack. Okay, maybe you are trying to writing, because some of you learning ARM. So ARM is different too. Okay, so if you have some idea, because you're learning machine assembly language, right? Writing for the ARM. I think most of you did. Okay, yeah. So that's why I look at those things. So for the ARM is the same. So you can even like directly access, because for the you can writing some pipeline and access to change the input, so you never realize it. Okay, or you can steal it, the information. And here's the information. I'm not really like go into details, so you just have a rough idea looking at it. And one more thing is about the relocation. So maybe the compiler, they doesn't know where the code will be. So right here, and then when they load into memory upon execution. So that's why we need to, okay, doing the dynamic and checking, okay, those are executable files. And then right here, when we are assigning, so we can modify based on this. So when we try to doing the object jump, and then we try to move it from the location. Wait more. And will be right here, and that's it for this part. Roughly, let me close it. Okay, let me go back. Yep. And for the lecture part would be covered to this part about our the malware analysis and also the reverse engineering. Have an idea? And of course, for lecture part, maybe we talk about more some strategy plan, some ethical things. And for the lab, I will try to add more practice, like how to executing and then do analysis. Okay. And the next one, just need to know we're going to prepare this one. Okay. Maybe some of you have difficulties. I know VMware Fusion. Yes. Right now there's a session step. I can make a screenshot, but also you can look at it. Pretty easy. You just go to the VMware official website and then looking for the Fusion. But I think they right now request you to sign in and then agree with the license, and then you can download and install it. And maybe some of you using the Windows, or like you using the Apple Silicon, the M series. I'm using M4 right now. Okay, I try to do it. So they do also available for M series or Intel. Okay, they can detect your system and let you to download. So far will be okay. And I know another one is the Oracle. They have called a virtual box. Okay, yeah. If you do have difficulty, then you can change to VirtualBox. So it's not like really have say, okay, I know different people have different preferences. Okay, as a programmer, you can insist on something you prefer, you enjoy more. Okay, feel more convenient. So if you think, okay, I want to use VirtualBox, you're welcome to do it. Okay. So no matter how, just create a virtual environment, the virtual machine, and we can doing some testing. So we can try to do it. Okay. And that's it for today. Any questions? No. Okay. No question.